So I have to start from the beginning. Okay. Anyway, those who came late also for you, I'll just explain to you the question once, then I will come back. Once again, I'm explaining the question. What is given here is the rate of increase of bacteria is proportional to the number present. What we did is we took x as a number at time t. Then rate of change of bacteria is dx by dt. So what is given to you is dx by dt is proportional to x. Then it said it is found that it doubles in 4 hours. When time is 0, we assume the bacteria's total number of bacteria is n. In 4 hours, x became 2n, doubles in 4 hours. Find the number of bacteria increased in 12 hours. How many times the bacteria has increased in 12 hours? So when t is 12, how much is x we have to calculate? Did you understand this whole question? Okay, now we'll see how to solve it. Now for solving, we started this way. Let x be the number of bacteria at time t. So dx by dt is proportional to x. From there I got dx by dt is k times x. Remember, k is a positive number because when x is increasing, when time is increasing, x also increases. But there can be a question where x is decreasing. In that case, I'll put minus here. Now I'm solving the differential equation. Brought all x with the dx, all t with the dt and integrating. So I get log x is kt plus c. Now it is up to you to whether to remove the log or not. I'm not removing. Some books will remove the log in the beginning. I can remove the log later. Now I'll use the initial condition. There are two unknowns here, k and c. Both can be obtained by this two condition. When time is 0, x is n. And we have put, they have not given us what is the initial number of bacteria. So I put the letter n for the initial number of bacteria. So log n is 0 plus c. So from there I get c is equal to log n. So one unknown I've obtained. Let me put a box for it. Now I need to find the other unknown. So I'll put this back here. So the log x is kt plus log n. Now I'll use the second condition. When time is 12, time is 4, x is 2n. So log 2n is k into 4 plus log n. Again, log 2n minus log n is 4k. So log of 2n upon n is 4k. So here I got k is also 1 by 4 log 2. So I got k's value. So in my equation, everything I've got, now I'll substitute in this. So I can write now log x is k by 4. Instead of k, what I'm writing? 1 by 4, sorry. T by 4, that means. T by 4 log 2 plus log n. Now I'm going to remove this log from here. So I can write this as log 2 raised to t by 4 into n. So the number of bacteria at any time x is given by this formula. N times 2 raised to t by 4. Now we want to find out what is the number of bacteria or how many times the bacteria would have been grown, number of bacteria would be grown when time is 12. So when t is 12, I can write x is n into 2 raised to 12 by 4. That is n is equal to n into 2 cube. That is 8n. So how many times the bacteria would have been grown by then? It would have grown by 8 times. So your answer is 8 times. Bacteria are grown by 8 times. That's how we can solve this problem. Almost every problem is in the same format. So hardly much difference between the questions. Only sometimes they will give you the value of n and ask you to calculate the numerical value. Otherwise, most of the questions are in the same format. They ask you, even practical, they'll ask you this question. So you need to learn it. Now let's do one problem yourself. I want you to do this problem yourself. Let's read this Newton's law of cooling. A body cools from 80 degrees to 50 degrees Celsius at a room temperature of 25 degrees in 30 minutes. Find the temperature of the body after 1 hour. Do you know what is Newton's law of cooling? A rate of change of temperature is proportional to the temperature of the body, difference between the temperature of the body and the surrounding. This is Newton's law of cooling. Theta is the temperature at time t. Then rate of change of theta, that is d theta by dt, is proportional to the difference between temperature of the body and the room temperature. So here the room temperature is 25. So this will be the equation at which we have to solve. Instead of theta naught, we'll be putting 25. Then when time is 0, the temperature of the body is 80. The temperature is 80. So theta is 80. When time is 30 minutes, so I'll take it as half an hour. When t is half an hour, theta became 50. When t is 1 hour, what will be theta's value? That's the question. I hope you understood the question. Yes or no?
Yes,
Yes,
sir.
sir.
Okay, then start writing the solution. So statement will be, let theta be the temperature at time t. So we define the variables theta and time. Then by Newton's law of cooling, d theta by dt is proportional to theta minus theta naught. So I can say d theta by dt is proportional to theta minus 25 degree. So d theta by dt is k times theta minus 25. So d theta upon theta minus 25 is k times dt. Now let's solve this. So integral d theta upon theta minus 25, we brought all the theta terms with d theta, k integral dt plus c. So log of theta minus 25 is kt plus c. Now we need to find two unknowns, k and c. For that they have given us, when time is 0, theta is how much they give us? Theta is 80. Theta is 80. And when t is half an hour, theta is 50. Use these two conditions and get k's value and c's value. So we'll apply the first one. So substitute log of 80 minus 25 is 0 plus c. So log c is log of 55. Now we'll find out k's value. So before that, I'll replace this back over here. Log of theta minus 25 is kt plus log 55. Now we'll put t's value as half an hour. That time theta became 50. So I can say now log of 50 minus 25 is k times half an hour is t is half plus log 55. So log 25 minus log 55 is k by 2. So log 25 divided by 55 into 2 is k. So we got k's value also. So if you substitute in equation 1, log of theta minus 25 is in 2t log 25 by 55 plus log 55. So what I done? I replace k here. So k is 2 times log 25 by, so you can simplify this. Log of theta minus 25 is, now what I can write this as, if you divide by 5 by 11, so log 5 by 11 raised to 2t into 55. So theta minus 25 is 55 times 5 by 11 raised to 2t. Now what we want to calculate? We need to calculate what is the value of after 1 hour. When time is 1 hour, what is theta? So when t is 1 hour, theta minus 25 will be 55 into 5 upon 11 the whole square. Now we can calculate this. So 55 into 25 upon 11 into 11. So this goes 5 times. So 125 by 11. So I can write here, I'm removing this from this point. So I'll write in a different color. So theta minus 25 is 125 upon 11. So theta minus 25 is 11 point, so 121, so 40 is 333. 33, 7 means around 6. So theta is 25 plus 11.36. That gives you 36.36 degrees Celsius. So this is my final answer. So I can say when time is 1 hour, the temperature of the body would be 36.36. So we have to write the final conclusion. Hence, when after 1 hour, the temperature is 36.36 Celsius degrees Celsius. Is it okay? Is it difficult? Everybody followed? Yes or no? So what will you take X as? X is the number of bacteria, and dx by dt is proportional to X. Number is increasing. So dx by dt is equal to k times X. Solve it. When time is 0, X is 1000. When time is 1, X is 2000. X doubles, number of doubles in 1 hour. When time is 2.5, what is X is you have to calculate. So there's hardly any much difference between this problem and the problem that we did before. Okay, let's do that. So all the questions are almost same kind. There is hardly any difference between the questions. So X be the number of bacteria at time t. So dx by dt is proportional to x. So dx by dt is k times x, where k is positive. So dx upon x is k into dt. Integral dx upon x is k integral dt plus c. So log x is kt plus c. So this is going to be fixed for every problem, wherever the number of bacteria is proportional to the number present. This statement is ever population or bacteria, everything. This part is going to be fixed. The second part only changes. When time is 0, x is 1000. There are 1000 bacteria initially. So log 1000 will be c. So always c will give us the initial value. So log x is kt plus log 1000. Then they are given us doubles when t is doubles in how many? 1 hour, correct? Doubles in 1 hour. So when t is 1, x is 2000. So log 2000 is k plus log 1000. So log 2000 divided by 1000. I hope you understood division. So k is log 2. Hence, I can now write the complete equation. So when I replace everything in the equation, what I get? Log x is equal to k became log 2. So t log 2 plus 1000, log 1000. So log x is equal to log 2 raised to t into 1000. So x is 1000 into 2 raised to t. Now what they have asked us to calculate? They have asked us to calculate the number of bacteria after 2.5 hours. So x will be, when t is 2.5 or 2.5 years, is 2 raised to 2.5. How to calculate that? 2 square into root 2. That is 4000 into root 2. Root 2's value they have given us as 1.414. So when you multiply this, you will get 5656. So number of, it is, since it's number, you don't have to take the decimal part. So x will be 5656. So number of bacteria is 5656 after 2.5 hours. So this will be your answer for this problem. A right circular cone has height 9 centimeter and radius of base 5 centimeter. It is inverted. Height is 9. It is inverted and base is 5. Radius of the base is 5. It is inverted and water is poured in it. At any instant, water level rising at the rate of pi upon A. A is the area of the water surface. So imagine at a particular instant, the water level is like this. That time, let's take the height as x. At that time, height is x. Remember, the radius will not be the same as 5. Radius will be different here. So we'll have to calculate that. Now they are given us only this much. The rate of change of height, dx by dt, is equal to, they are given us equal, water rises at the rate of pi upon A centimeters per second. That means everything is calculated in centimeter. A stands for area of the surface. That means they are asking you area of this circle. So area of circle is pi r square. But r is keep on changing according to the height. So there is a relationship between this r. There is a relationship between r, x, and also this triangle. You can see a similarity in triangle. So I'll explain to you that. So just will note the data here. So let me draw it properly in the screen. You can also draw with me. Then it's the inverted cone. So the height of this cone is how much? The height of the cone is 9 centimeters. Everything is in centimeter. And radius of the cone is 5 centimeters. Then we have the level, water level here. This is a water level. At time t, this is a water level. Then we have the height of the cone. And we also have the radius. What you notice is this triangle which I formed here. Let me take as O, A, B, C, D. Can you tell me the relationship between these two triangles?
Similar triangles.
Similar triangles. If that similar triangle OA upon OC and AB upon CD will be equal. From that you can take R in terms of X. Unless you write R in terms of X, we will have, otherwise we'll have more than two variables. So this type of problem where there are more than two variables, the relationship between two variables should be derived by using some extra condition. So I'll start like this. Let X be the height of the water level. At time t. And the radius of the surface at that instant is equal to R. Then from above diagram, what you can say, triangle OAB is similar to triangle OCD. Therefore, OC upon OA is CD upon AB. OC is X. OA is 9 centimeter. CD is R. AB is 5. Which implies R is 5 by 9 of X. So now we have only two variables in this whole equation. One is the height and other is the time. So what is given to us is the relationship between X and A. So I can write next page I'm writing. Rate of change of water level is given to be pi upon A, centimeters per second. So dx by dt is pi upon pi r square. Now there are three variables here, but we are allowed to have only two variables. So dx by dt is 1 upon pi got cancelled. Instead of R, what will you write? R is 5 by 9x. So 5 by 9x. So I can write x dx into 9 is correct. No, 9 will go to numerator. Or let it be 9 by 5 dt. So when you integrate x dx is 9 by 5 integral dt plus c. So x square by 2 is 9 by 5 t plus c. So I can write x square is, okay, let it be like that only. X square by 2 is 9 by 5 t plus c. When time is 0, the height x is also 0. Do you agree with the statement? Water is filling. When we started filling the water, when time is 0, there was no water in this vessel. So I can say when time is 0, x is 0. So that is not given in the question. You need to understand yourself. So in that case, 0 is equal to 0 plus c. Therefore, c is 0. So now x square by 2 is 9 by 5 times t. What we have to calculate? Show that vessel will be full in 75 seconds. Okay, so we have taken time in seconds. So when will that be full? When will this vessel will be full? What will be the value of x when it is full? Tell me. At time t,
9 centimeters.
yeah, 9. When x become 9, the vessel will be full. So when x is equal to 9, when x is equal to 9, what is t we have to calculate? So yeah.
Sir, dx by dt 1 upon 5 by 9x the whole square.
5 by 9.
The r,
Sir, R square substitution we have to do.
Is this correct?
Sir, first step.
second step.
5 upon
See, there it is R square and you have substituted only R.
R.
Oh, yes, yes. Oh. I do agree with this fault. Okay. So then we'll have to change the whole thing. Then the equation will change. So we'll have x square dx is 81 by 25 dt. So integrating x square dx, 81 by 25 integral dt plus c. So x cube by 3 is 81 upon 25 into t plus c. Again, when time is 0, x will be 0. So therefore c is 0. So x cube by 3 is 81 by 25t. So when x is 9 centimeter, that is vessel is full. So 9 cube upon 3 is 81 upon 25 into t. So t is 9 cube by 3 into 25 by 81. So 81, 3 will get cancelled, 3 into 25. That will be 75 seconds. So that vessel will be full, and therefore vessel is full in 25 seconds. 75 seconds. Is that okay? I think that
Yes.
problem is fine. So all types of problem I have completed. So the first point, what I explained to you is, whenever you say the spherical raindrop evaporates. So when you say evaporates, we are talking about the rate of change of volume. Is proportional to surface area. Surface area of sphere is 4 pi r square. V can be replaced by 4 by 3 pi r cube. which is proportional to 4 pi r square. Then what else we can say? The radius originally is 3 mm, and so when time is 0, r is 3 mm, and 1 hour later it reduces to 2 mm. When t is 1, and r will become 2 mm. Find an expression for radius drain drop at time t. So we need to only find the function. We don't have to find the value of any particular variable. So we have to find the relationship between r and t, and that's it. So let's try to solve this. So what are the variables we have in this problem? Let r be the radius. Of the droplet at time t. Then rate of change of evaporation, so dV by dt, is proportional to the surface area. So d by dt of 4 by 3 pi r cube is proportional to 4 pi r square. So 4 by 3 pi r cube, when you differentiate this, 3 r square dr by dt is proportional to 4 pi r square. What are the things can be cancelled? Let's cancel it off. So r square and r square also will get cancelled. So dr by dt is proportional to a constant. There's no variable in that. So I can say dr, instead of saying proportional to a constant, I can say dr by dt is a constant. Now dr is k into dt. Integrating, dr is k integral dt plus c. So it's a linear equation. R is equal to kt plus c. Now what they are given us? When time is 0, R is 3 mm. So that means 3 is equal to k into 0 plus c. Therefore, c's value is 3. Then they are given us when time is 1 hour, R is 2 mm. So we'll substitute here. So R is 2 mm when time is 1 hour and c is 3. Therefore, k is minus 1. Therefore, the function, what we can say about the relationship between r and time? So r is minus t plus c. C is 3. So that will be the relationship between r and t. So I can write like this finally. Therefore, r is equal to. Therefore, r is equal to 3 minus t. Remember, the domain of this function. What are the possible values of t? T can be 0 up to 3. So I can write the relation as r is equal to 3 minus t, where 0 less than equal to t less than equal to 3. This will be the function that is connecting the radius and the time. Is it okay? Any doubt? Question number 12. Radium decomposes at the rate proportional to amount present at the time. So again, dx by dt is proportional to x, but here you will write dx by dt is minus kx, because as the time is increasing, the amount of the radium is reducing. So you will put a negative sign for constant. P% disappears in 1 year. So X is the amount present. Can you say anything about this particular statement? P% disappears in 1 year. So when time is 1, let's say initially there are n amount of radium. After 1 year, how much radium will be there?
P by
From
100 of
n,
X.
how much will get removed? P% of n. Do you agree with that? So n into 1 minus p by 100 will be the amount of radium present. This is very, very important. That's why I did this problem. So it says disappears. So what is left? That you need to write as x. X is the amount present at that time. Then what percentage of radium will be left after 2 years? Here we can say when t is 2, how much is x here to calculate? Please start yourself. Everybody start this problem. %97% is not right. Okay, let's do it in let x be the amount present. At time t. So dx by dt is proportional to x. Dx by dt is minus kx. Since we have done this several times, so let me just directly complete through. When t is 0, let's say x is n. So I can say log n is equal to c. Then what does the next condition says? When t is 1, the number of bacteria x would be n minus p% of n. So n minus n into p by 100. When you take n common, 1 minus p by 100. So what you have to do that time is log x is equal to minus k. Instead of x, what you can write? Okay, I'll substitute here. Log of n into 1 minus p by 100 is equal to minus k plus log n. So I can say k is equal to log n, okay, minus k into 1 minus p by 100 minus log n. So substituting in the equation, let's substitute here. So log x minus k will become plus t log 1 minus p by 100 plus c is log n. Log x is log of 1 minus p by 100 raised to t into n. X is equal to n into 1 minus p by 100 raised to t. Now what you're asked to calculate? After 2, what will be the radium left after 2 years? When t is equal to 2, x will be n into 1 minus p by 100, the whole square. So the amount of radium present will be this much. So what will be the percentage of, in terms of percentage, how much it will be? So originally n was there. This is a present number. So the percentage would be n into 1 minus p by 100, the whole square upon n into 100. So n will get cancelled. So this will become 100 minus p upon 100, the whole square into 100. That will be the percentage. So how to make it match with the answer given in the book? Just look at what I'm doing. So that became 100 minus p by 100, the whole square into 100. So it is 100 minus p, the whole square. This 100 square and 100 will come only 100. That became 100 minus p upon 10, the whole square. So in the book they are given us 100 upon 10 is 10 minus p by 10, the whole square. So this is a book answer. So it will balance with it, the same method, there's no difference.